My name is Dumbajana from Group 29, and we are working on a project to detect a bovine respiratory disease. It's called AI-Livestock Care, and it's a reinforced deep Q knowledge distillation for bovine respiratory disease detection. So, when we start with what is bovine respiratory disease, so this is this is known as shipping fever, and it's a complex respiratory infection that affects cattle. It's one of the most common and costly disease in the beef and dairy industry, and it's mostly caused by a single pathogen or germ, but it's also multifactorial, meaning it is a result from a combination of viral infection, bacterial infections, and many others. Why is it a major concern? It is a major concern because it's a leading cause for illness and death in feedlot cattle, resulting in a significant economic losses. So, current detection challenges that are faced by farmers or cattle industry have a late diagnosis, high economic losses, and inconsistent manual detection. So, among the solutions that we are introducing, we have introduced a reinforced deep Q knowledge distillation model to detect the signs early, and how it improves this detection of this disease. It combines reinforcement learning and deep Q learning. It also uses knowledge distillation for efficiency, as well as multi-strategy learning for better generalization. So, going to the market opportunity, we want to market our model, uh, and we are targeting the dairy and beef cattle farmers. The bovine respiratory disease prevention and treatment. Uh, Veterinary clinics and livestock health consultants for precision diagnosis, as well as agri-tech companies for integration into smart farming solutions. And lastly, government agencies and policymakers for disease control initiatives. So going further to the technology stack, we have the machine learning, which uses the TensorFlow and Stable Baselines 3. Also, the deployment of the model. We use the fast API and renders the cloud, as well as the data sources that we want, all the ones that we have, and we are hoping to get when they to go further. So we have the IoT data sensors, clinical records, historical cattle health data, and lastly, the end user access. We have the web and mobile based applications. So going further to how this model works, data collection and processing. There's farmer monitoring and clinical records. I have the deep Q learning, and in this there is a reinforcement learning for optimal predictions, and knowledge distillation for model compression for faster inference. Multi-strategy learning, it's a hybrid machine learning approach, for adaptability. Going to the competitive advantage, we have the detection speed. By the traditional methods that were being used, or the ones that some people are still using, is delayed diagnosis, whereby when we bring this approach, there is a real-time AI analysis. And going to cost efficiency, there is expensive lab tests, whereby there are a lot of costs that are incurred. But with this approach, there are reduced antibiotics overuse. Going to the accuracy, the traditional methods are less accurate compared to this approach by this percentage. So traditional methods are 70 to 80%, and this approach is 90% above because it's self-improving. And lastly, scalability. The traditional methods have limited application, while this approach it has the cloud-based and API integrated interface. So going further, the business model. We have the key partners, value proposition, and customer relationships. So among the key partners, we have veterinary research institutions, IoT sensor manufacturers, cloud service providers like Azure and Render, and many others. We have agri-tech companies. And for value proposition, there's reduced uh, antibiotics overuse and like treatment costs. So with this approach, is improved cattle health and productivity, also scalability, real-time AI-powered detection for this disease, and customer relationships. You're targeting the direct collaboration with farmers and veterinarians, also AI model updates and customer support, training and educational resources. Then for the revenue model and monetization, the revenue streams, we have the subscriptions based AI powered detection services for that disease, and also one-time in licensing fees for the agri-tech companies, and also want to receive revenues from custom AI model development for enterprise solutions. Lastly, premium analytics features for advanced disease monitoring. Then for the channels, we want to use digital platforms like the web or mobile apps, API integration with the farm management systems, and also direct business-to-business partnerships with agribusinesses. And going to the cost structure and scale planning, uh, major costs in R&D. For example, we have model. There is model training and optimization. Then the data collection and pre-processing. Also, among the costs, there will be cloud computing and API hosting, and regulatory compliance and certification. And lastly, marketing and customer acquisition. Then going to the scalability strategy among the cost structure and planning scaling plan. We have the AI, we want to expand the AI models to detect other livestock diseases. Partner with IoT companies for automated data collection, as well as optimize model deployment for edge computing on farms. Then the future developments that we are hoping to do, and also the roadmap according to what we have. So far, we have the model development and validation, and the cloud development, deployment, and also the early adapter trials. So among the things that haven't yet developed, but we are planning to, we have large-scale commercialization and also expansion to other livestock disease and global markets. Then, so far, uh, with our approach, we are looking for partners, veterinary institutions, agri-farms, and research bodies, and many others. Why should they invest in us? So there is a high growth market, scalable AI technology, and strong industry demand for this solution that we have. Thank you.